Horizontal projectiles. When we talk about horizontal projectiles, we need to know a couple of vocabulary words. So the first thing we want to talk about is what a projectile actually is. A projectile is any object that is hurled through space and continues its motion without outside assistance. So good examples would be a baseball or a bullet or a ball rolling off the ends of tables. We need to know that when we talk about the path that a projectile takes, we're talking about the projectile's trajectory. And when we deal with the trajectory, that shape, that path, is called a parabolic shape. And really a parabolic shape means that it's a curve. And when we talk about that curve, the top part of the curve is called our apex. And if we were to look at the shape of the curve before the apex and the shape of the curve after the apex, those two sides are identical. And since the path of our projectile is curved, we know that that projectile is accelerating because its velocity is changing over time. The last term we need to know is what's called our range. And the range is the horizontal distance traveled by the projectile. Let's talk about some properties of horizontal projectiles. When we talk about projectiles, they move in two directions at the same time. Horizontal projectiles are moving in the horizontal direction, and they're also moving in the vertical direction at the same time. When we look at the horizontal direction of a projectile, we need to know that the velocity is constant in the horizontal direction. It's going to stay the same. There's nothing acting in the horizontal direction to speed up or slow down the projectile. But when we talk about the vertical direction, we need to know that our projectile will be accelerating. Because when we talk about the vertical direction, we're talking about the fact that the motion of that projectile is going to be affected by gravity. We know that gravity always works in the downward direction, so the speed of a projectile will be going down as it rises, and the speed of the projectile will be going up as it falls. When we talk about the horizontal and the vertical components of a projectile, these two velocities are independent of each other. And what that means is that they have no effect on one another. We need to know that horizontal projectiles are projectiles that are launched parallel to the surface of the Earth, not at some angle to the Earth. We're going to look at particular problems that help us to solve the range for a horizontal projectile. In other words, how far in the horizontal direction will a projectile be once it stops its trajectory? So we need to know the vertical height of the launcher. We're going to label that as d sub v, which is the vertical distance. How high is the launcher off the ground? We're going to use that value to calculate the time that the projectile is in the air. And we also need to know what the initial velocity of the projectile is. And that velocity will be in the horizontal direction, so we'll label it as v sub h, which stands for the horizontal velocity. And we're going to use that to calculate the horizontal distance or the range of our projectile. And we'll symbolize that with a d sub h for horizontal distance. And again, just as a reminder, when we talk about horizontal projectile problems, the launcher has to be set for a horizontal launch. Has to be set at 0 degrees, not at some angle from the Earth. So we're going to have 2 steps in this kind of problem. The first step is going to be to find the time that the projectile is in the air. And to calculate time, we're going to take the square root of 2 dv over g. So the steps in this problem are going to be to multiply the vertical distance times 2. We're going to divide that value by g, which remember is 10 meters per second squared. We're going to press our equal sign so that we have a value underneath that square root sign. And then we're going to press the square root button, and that'll give us the time in the air that our projectile spends. Once we have that, we'll be able to calculate the horizontal range for our projectile. And the equation that we're going to use for that is d sub h equals v sub h times t. So in other words, the horizontal distance, or the range, equals the horizontal velocity times the time. So our steps in our calculation are going to be to multiply the muzzle velocity, which is our initial velocity or our horizontal velocity, and we're going to multiply it by the time that we got in step number 1 of our calculations. So let's look at a sample problem. How far from the bottom of a 45-meter tall cliff will an arrow strike the ground if it is shot horizontally with a speed of 150 meters per second? So the first thing we're going to do is we're going to draw our picture. So we'll have our cliff. And when we look at the problem, it tells us that we've got our bow and arrow at the top of the cliff, and the height of the cliff is 45 meters. When we fire the arrow, the horizontal velocity is 150 meters per second. And remember that the velocity in the horizontal direction doesn't change, but the velocity in the vertical direction will change because of the acceleration due to gravity. So now when we think about our arrow, it's going to follow that curved trajectory until it hits the ground. What we're ultimately trying to find is this value here, which is our range, or our distance in the horizontal direction. So we've got 2 steps in our problem. In step number 1, we want to calculate the time that the arrow is in the air. So we know that our vertical distance is 45 meters. We know that our vertical or our horizontal velocity is 150 meters per second. So we're going to take our equation time equals the square root of 2 dv over g to calculate the time that our arrow is in the air. So we'll substitute in what we know. We've got 2 times 45 meters divided by 10 meters per second squared. So we've got 2 times 45, that's going to give us 90. We're going to divide it by 10, that's going to give us 9. So we've got the square root of 9, and our units that we're going to be left with are seconds squared. We're going to take the square root of 9 and the square root of seconds squared, and that's going to leave us with 3 seconds. That means it takes 3 seconds for our arrow to hit the ground. Now we're going to do step 2. And in step 2, we're going to calculate the horizontal distance, or we're going to calculate the range of our arrow. So our horizontal distance is going to equal the horizontal velocity times the time. We were given the horizontal velocity, so we'll plug in 150 meters per second. We calculated the time in step 1 as 3 seconds. So we'll take 150 times 3. The horizontal distance is 450 meters. That means that if we have a bow and arrow 45 meters above the earth, and we shoot that arrow with a horizontal velocity of 150 meters per second, it will take 3 seconds for that arrow to hit the ground, and the arrow will be 450 meters away from the end of the cliff. If you need to go back and listen to this again, or after you do a couple of practice problems, you want to look at the solutions again, you can go back and do that.